Hey class, to keep this video short, I'm going to annotate over the key that I sent you. So just to get going, proportions, pretty important thing to consider here, knowing that two ratios are equivalent. So a lot of times what's going to happen is we're going to have a missing part of the ratio that we want to try to find. This actually has come into play a few times when I've looked at if I left teaching, what do I have to make since I'm only working 9 months of the year, what should I be making if I'm working 12 months of the year? Like basically what's the minimum I should be making if I left teaching? I would never do that because it's the bomb. But if I did, there's been times where it's like, man, this is hard. And I've had to make that proportion there before. So kind of an interesting thing to consider. So cross multiplication is usually the skill that we use, which again is different from cross canceling. Okay, so again, cross canceling, that was what we did yesterday, where if I had to reduce this random fraction over here, I would try to divide the top and bottom by something, giving me 5/3. Again, that's cross canceling, whereas cross multiplication is when you multiply across an equal sign. So 4.5 times 160 gives you 720, and 6 times x gives you 6x. Getting x alone from there, you just divide by 6 on both sides, leaving you with 120 equal to x. So again, this is not how much does Evan need to make in order to leave teaching, but a similar scenario where this could possibly work. If we're going to Atlantic City, it's 9.5 inches on the map, and the actual distance is 680 miles. If I'm going to Orlando and that's 15 inches, how many miles would that be? So my goal is to try to set up the proportion. If I say that 680 is related to 9.5, I have to have that same miles over the inches again. So again, notice here that's 680 miles to inches. And if I do miles over inches, I would have to do miles over inches again. Okay, you want to be consistent there when you set up that proportion. From there, we just cross multiply again, and then leaving me with 15 times 680, and then 9.5 times x, and then I would divide by 9.5 on both sides, giving me this final answer right there. You don't always have to cross multiply though. Honestly, an easier way to solve this one would have just been to multiply by 15 on both sides in order to cancel out those 15s, and you could have just multiplied that ratio by 15. Either way works. It's kind of whatever makes most sense to you. Similarly, in the fish for the biology class here, they're catching 37 fish, and then they're tagging them and releasing them back. So again, we've got 37 fish up here. It says a week later they catch 80 fish and find that 6 of them are tagged. So again, that's 37 fish tagged out of the whole thing, and then it was 6 fish tagged out of the total. Okay, so the total for when they only caught 80 was 80, and then the total in the lake we don't know. And so a way to guesstimate would be to cross multiply from here, and again divided by 6 on both sides to give you 493. Again, what an example of something that would not work would be something like x over 37 and 6 over 80, because that's fish tagged over total and then total over fish tag. So we want to be consistent. Hopefully you're seeing that consistency piece play out here. So matching parts, looking here, when we have this proportion, the recommendation is to read the numbers straight across the numerators. There should be a connection, and I was kind of hitting at that in the above question there. So if we have a bag of apples and there are 3 green for every red, okay, if there's a total of 24 apples in the bag, how many are red? So if I set the proportion in this way, would it result in a correct answer? The answer would be no, because if we look at our units here, it's 3 green to red, and then it's red to total. So again, that's not consistent there. Red would have to be in the bottom, and then we would have to be looking for the green. If they would have done something like, if they would have changed it up to maybe make it like 5 red apples to the total, which was 8. Like in a separate scenario with this ratio there, if there was 5 apples, red apples for every 8 total, and then there was a total of 24 and an unknown amount of red, that's red over total and red over total. So that would be an okay. That's like a corrected proportion right there. Again, the issue there is that the denominators don't match. Direct variation. So the reason why this is considered proportional when it's like y equals kx, I think it might be a little bit easier to see that as y over x equals k, where k would be like a specific number. So an example would be like y over x equals 3, where you can divide the two numbers and get a specific output there, not a bunch of extra stuff like that. So when you can divide x and y and get the specific number. So in this case, if you're trying to get x by itself, you could write it as y over x equals 4 over 5, and then that 4 over 5 is in that k spot. Or you could have just seen like 4 over 5 is literally just perfectly matched up with that k spot right there. So both of these are fine to think about direct variation like that. It just has to do with the concept of proportionality. So again, the answer for number 6 would be no, because it's not in that y equals kx form. The issue is that extra -5 right there. That extra -5 is not helpful. And again, if I solved for x and y on the same side, which is what I was getting up there, I would have y plus 5 equals -2x, and then y plus 5 over x. The fact that the extra 5 is there, that again is also the issue of why it would not be considered directly a direct variation situation or directly proportional. So again, looking here, are x and y proportional? So again, we either want to have it as y equals kx or y over x equal to k. Whatever kind of makes the most sense in your given situation is what you want to look at. And so as I looked at this table, I noticed it went up 1, up 2, up 3, but I only went up 1, up 8, and then -4. So that's kind of like inconsistent there. If it was like +1, +2, +3 again, maybe that's something that we would want to have. But again, it's not like a predictable pattern as of right now when we're just kind of counting up like that. Similarly, in number 8, it goes up by 2, up by 1, up by 2. And again, when I say that, I'm saying like 2 plus 2 is 4, 4 plus 1 is 5, and 5 plus 2 is 7. So again, that's kind of how the x's move. And then the y's, they went up 6, up 3, up 6. And so it looks like it's a consistent pattern there. And so we would say that that is going to be directly proportional. Another way to look at it, if you wanted to make it harder on yourself, you could have done like 6 for number 7. 6 over 2 is 3. 7 over 3. Again, this is looking at that x over y concept. 7 over 3 is not 3. 7 over 3 is a decimal. I'm going to screw this up. 2.3 repeating. So just the fact that those are not consistent would again be a reason why it's not proportional. And then down here again, if you wanted to do all the work, you could have done 6 over 2 equals 3, 12 over 4 equals 3, and then 5 over 15, 15 over 5 is 3, and 21 over 7 is 3. Any of those situations would have worked for you. And again, notice that 3 is in the K spot, and then if I divide X and Y, 3 is what I get. So my constant of proportionality is K, is 3. So last couple questions here. Hopefully I'm not going too quick for you. So we're looking at some books being sold. And this part over whole concept is pretty helpful when we're dealing with a percentage. So like if I have to, if 25% of my income is taxed, the part is the 25%, and the whole would be 100%. So that's why it's percent over 100. And a lot of times it's like that is over of concept can work as well. So we've got 34,300 copies of a book is sold in the first month, and that represents 7.1% of the number of copies sold to that date. So how many copies have been sold to date? So if we are saying that the 34,300 is 7.1% of 100, we would say that that 34,300 is some percentage of an unknown number. Okay, so again, it's that is over of, so that's why the missing part is in the denominator there. And again, it's not the total. So again, that total, I like the word total more personally. That total is what we're looking for, and it would have been 400,000 copies that is found there. Again, you would have got that by cross multiplying and then dividing by 7.1. So again, 7.1x equals 34,300 with 2 more zeros. And then you would have divided by 7.1 on both sides to get the x equals 483,099 copies. Last one here. So our house, this is great. I would love if this would happen. A house is increased by a value of 29% since it was purchased. The current value is 129,000. What was the value when it was purchased? So this is kind of getting at the concept from the previous page that you could have done, where you had that old value times however much it went up or down, and then the new value. So if it was a 29% decrease, so a separate example is 29% decrease, we would have wanted to do some old and then times 71.71 equals whatever the new value is be. So again, the reason why I added 0.29 was because it was an increase. That's not the only way you could do it. If you're using it from the notes right here, you could have also, again, that purple over there was a separate example of a decrease situation. So if you wanted to do a situation with the proportion, you would have done 129% over 100 equals the 129,000 divided by that old concept there. You could have done it like that if you wanted to as well. So lots of different ways. I think the reason this can get so complicated is because there's so many ways to do it that would yield the correct answer. So hopefully that's making some sense. Appreciate you guys giving good effort. And yeah, thanks for being here.